Hi guys, I was asked by one of you to do a video on division, so here it is. So this video is going to be how to divide large numbers and how to interpret the answer. So dividing large numbers, specifically when they're 2 digits or more, is typically referred to as long division. That name is not important, but just so if you see it somewhere else, you'll know what they're talking about. Alright, so first thing so there's two parts. There's how to actually do it and what the answer means. First is the prerequisite. So if you guys are not comfortable multiplying numbers that are 1 through 10 by 1 through 10, such as 7 by 9, so basically your times table, if you're not comfortable with it, you should be able to do any number from 1 through 10 by 1 through 10. If that's not the case, you're going to find this video too advanced and you won't be ready for it. So you may want to go back and review that. Alright, so with that out of the way, let's jump in. So I want to make this as easy as possible. So let's go to example 1, which is right over here. So normally we have, let's just say, our times table. From the times table, you should know that 8 times 6 is 48. So 48 divided by 8 is just 6. So now let's put this in our sort of division format, and we're going to be using this format for all the work. And so that's why I want you to start getting comfortable with this. So the 48, which is the number we are dividing, goes on the inside of this looking thing. That's just a convention to have this shape, which is just this horizontal bar with this little thingy over here. So that's what we're going to use. So that goes inside, and what we're dividing by goes over here. So 48 divided by 8, well, we know from our times table that's just 6. So you may think, like, what's the point of doing all of this stuff here? But that's just so when it gets crazier, you'll know where that stuff's coming from. So just follow along in this simple example. So 48 divided by 8 is just 6. And to check that, what is 8 times 6? That's this second 48, which we're going to write below the original 48. So we're going to subtract it off and get 0. So 48 minus 48 is 0. That 0 tells us that there is no remainder. That means if you multiply 6 by 8, it goes perfectly into that 48. Alright, so maybe that was a little too boring. Let's go into a slightly harder example. So here's example 2. So now we have 49, which is not divisible by 8, not divisible evenly by 8. So we can't fit a whole number of 8s into 49. So the best we could do is 6. So that's 6 times 8 gets us this 48. So we're going to subtract it off to see what's left. So that's the 1. So that means we have a remainder of 1. So that's how it basically works for these easy cases. And there's really not much in the way of like learning a new division method, because you already know your times table, so you could see that, hey, this has to be a 6, because if I make it a 7, then 8 times 7 would be 56, and then we've overshot the 49. So in other words, we never want to overshoot the number. That's why we pick the number that's either equal to it or just under it when we multiply these two. So 6 times 8 is the last number that's below 49. That's 48. And in the first example, we nailed it exactly. So you don't want to pick something that goes over, such as 7, 8, or 9. Alright, so that's these first two examples. So these examples are going to get progressively more complicated. So if you can't follow a certain example, make sure to go back to the previous one. So here's example 2. Now let's go to example 3. So all we're going to do for example 3 is just make this inside number larger. So that's over here. So now instead of taking 49, we have 4,900. So how do we divide 4,900 by 8 step by step using this method? We're going to do the same thing we did over here, which is first take this 49 part. Now I've circled the 49 and highlighted it because no amount of 8s go into 4. That would be a 0. So 0 8s go into 4. So that's why we took the first 2 digits and not just the first 4. So we're going to start with just like the smallest piece we need, which is this 49. So 49 divided by 8 is 6. 6 times 8 is 48. And so now we see what's left. 49 minus 48 is 1. Cool. Now this 0 is going to be dropped down. So the way this procedure is always going to work is you're always going to drop down one new digit at a time every time you do a new step. Alright. And so also we're going to subtract off the new part. So in this case, the new part, we just came up with the 6, so we're subtracting that 48. So we get this 1. So we dropped in the first 0, so we have a 10. What's 10 divided by 8? That is 1. So now we see what's left to do. So that's 1 times 8. That's this minus 8. So 10 minus 8 is 2. Now we drop down that next 0. So we have 20 divided by 8. 20 divided by 8 is 2. So that means that's where we get the 16. So where might, like for example, why didn't I make this a 3? Because 3 times 8 would be 24, and that's over what we want. We don't want to exceed the number. We want to be at it or just under it. So that's the closest we could get is with the 16. So 20 minus 16 is 4, and no amount of 8's go into a 4, so that's it. That's our part remaining. That's why we call it the remainder. So that's what this R4 means. It just means 8 times 612 gets us pretty close to this, but then we have a remainder of 4. So 612 would be your answer, but then the leftover part is a 4. So depending on what your teacher or what you want to write, the answer is either the 612 or this whole thing. All right, so that's example 3. Let's go to, well, before we do that, let's understand what just happened. So this 612, that 6 is not just a 6. That 6 is a 600 because it's in the hundreds place. So let's see how this actually is correct. If we have 8 times 600, we get to 4,800, which is pretty close to 4,900. If we try 700 instead of 600, then 7 times 8 is 56, and tack on 2 zeros, we would be at 5,600, so we would be over. So that's why 600 is the best we can do for this first hundreds digit. Now we're at 4,800, so we have 100 left to go, and if we take that 1 is not just a 1, it's a 10 because it's in the tens place. So 8 times 10 is 80. And then that 2 is just a regular ones digit, 2. So 8 times 2, 16. So if we add all this up, we get 4,896, which is 4 away from 4,900, hence the remainder of 4. All right, so make sure you followed this large number here divided by a small number here example, because it's going to get more complicated. All right, here's example 4. Similar to example 3, except this time I've circled and highlighted this 9 because we're not going to grab the 94 because we don't need to grab the 94 because an 8 goes into a 9. So that's why I put this 1 here. So now 1 times 8 is an 8, 9 minus 8. So in other words, that gave us this 8. What's left over? 9 minus 8 is 1. Okay, so we have another 1, but we always drop down the next digit. That's where this 4 came from. So now we have 14 divided by 8. Well, the closest we can get is with another 1. So that's where the second 8 came from. 14 minus 8 is a 6. And then we just bring down the next digit, which is the first 0. So 60 divided by 8, the closest we could get is 56. And that's 8 times 7. That's where the 7 came from. So we subtract, that should be a minus. Subtract that 56. We're left with a 4, but then we drop down the next digit. So it's a 40, and 8 goes evenly into 40 5 times. So that's 40 minus 40 and 0. So there's nothing left over. That's why the remainder is 0, or you don't even have to write anything here, but just to be clear, I wrote remainder 0. All right, so that's this example. So by the way, when I write all this stuff, this 14 over here, it literally means 1400, but there's no point in writing these zeros and then writing these zeros because we've aligned everything properly. So it's understood that there's a ton of zeros that we're not writing. So make sure that that makes sense. So if you want to write the zeros, you can, but it's a waste of time if you're trying to do this fast. So understand that anytime I have a ton of these empty spaces here, they're all filled by zeros, and that's gonna relate it back to why that worked. All right. So again, we're not gonna actually write these when we do this as a pro or a master, but in understanding it, it might be helpful to think about them. All right, so example 5. So now we're gonna have a large number that we're dividing by a pretty large number. So dividing by 31, which is not a one-digit number, so this is gonna be a little more annoying. So let's see how to do this. So we're not gonna grab the 1 because no 31s go into a 1. We're not gonna grab the 12 because no 31s still go into a 12. But 123, now 31 can fit into that. And specifically, it fits into it 3 times. Unfortunately not 4, because that would have been 124, so we just missed it. That's why this has to be a 3, not a 4. So 3 times 31, that's where this 93 came from. We subtract these two numbers, we get a 30. Drop down the next digit, which is a 4. So now we have 304 divided by 31. That's going to be 9, because 9 times 31 is 279, and that's the closest we can get with one digit. So subtract these, you get 25. Drop down the next 5, so now we have 255. How many 31s fit into this? That's going to be 8. That's where that 8 came from. 8 times 31, it's going to be 248. Subtract these, you get a 7. Drop down the next digit, you get a 6. How many 31s fit into 76? That's right, 2. That's where that 2 came from. So now 2 times 31 is 62. So what do we have left to cover? We have 14 left to cover, but we also have to bring down the next digit. So 147 divided by 31 is going to be, like I said, it gets a little tougher with these larger numbers, but that's going to be 4. So, by the way, if you mess up, like let's say you pick 3 or 5 and you notice it's wrong, that's fine. Just you could do a side calculation. You don't have to always get these right. So as you practice, you'll be able to do larger and larger numbers. So 147 minus 4 times 31, which is 124. And when you do that, you get 23, and that's it. No more 31s can fit into this, and there's nothing else to bring down. So that's how you know you're done, and that's your remainder. Boom. Okay. So that's how you divide large numbers. So now we're going to go over interpreting the answer. So we've gotten all these numbers and all these remainders, but it might be a little confusing what to do from here. All right. So I've written some stuff here for completeness, but don't freak out. So this left part here, I would almost recommend kind of ignoring it, but if you need to know what all these terms are called, you may have heard dividend, divisor, quotient, remainder. I'll be honest, guys, when I first saw all these terms, they freaked me out and I couldn't remember any of them. So try to see if it makes sense with the numbers and then just figure out which terms are called what later. This is not that important for now. All right, so let's just do an example. My main point in giving you guys this example is that you're going to see a lot of different looking things, but they all mean the same thing. So that's why I put same. So here's the basic example. 25 divided by 8. Now I'm picking simple numbers so you guys can follow it easier. So 25 divided by 8 is 3, and then there's a remainder of 1 because that's going to be 24 and there's 1 left over. Now you may see it with this division sign. You may see it as this fraction, this bar sign, 25 over 8 this way. You may see it written in your long division setup like this, 25 divided by 8, 3 remainder 1. So all of this stuff means the same thing. Now here's the key point. When you're done, we write this remainder of 1, but that's not always going to be the case. So another way of interpreting this, which still has this remainder of 1 kind of thing, is to say, well, 25 is 8 times 3 plus 1. In other words, when you see it this way, this is the part that you kind of got close to 25 with, and that's that annoying part. That's the remainder that didn't work out. You still have 1 left over to get you to 25. So that's one way of thinking about it. These are kind of related. This is the remainder way of thinking about it. But you might not be interested in that. You might be interested in not having a remainder. Like, I want to know exactly what it is with no remainder. So in that case, I just wrote it this way as a fraction, let's say. So 25 over 8. And some of you have worked with fractions, some of you haven't, doesn't really matter. So this just think of this as 25 divided by 8. This is just another way to write it. What is 25 divided by 8? Well, we've said it's 3, right? But then there's 1 left over. So in terms of fractions, if you were to simplify this fraction, for those of you that are familiar with fractions, this would be 3 1/8. Now, I want to show you guys kind of 2 ways of doing this. So for those of you familiar with fractions, I would think about it this way. Just simplify this and you get 3 1/8. For those of you not really familiar with fractions, let's think of it this way. So we're going to take this above step, and all we're going to do is divide everything by 8. So what happens there? 25 divided by 8, well, that's 25 over 8. I just wrote it. What's 8 divided by 8, nothing, so that's why this is just the 3. So 8 times 3 divided by 8 is just the 3. So in other words, I'm going to take 1, 2, 3. Each of these 3 are getting divided by 8. Because you can't just do divided by 8 on the right. To keep an equation equal, you have to divide everything, like you have to do the same operation to everything. So the left side is getting divided by 8, the right side is getting divided by 8. So the left side, that's where we have this. And then the right side, all of this is getting divided by 8, which we can split up into 2 parts. So if you get rid of that 8, we just have that 3. And then this is where this new 8 comes from, because we've divided everything by 8, so that 1 is now 1 over 8. And if we add them up, that plus is just that plus. We get 3 1/8. So what point am I trying to make here? You could think of 25 divided by 8 as 3 remainder 1, or you could think of it as 3 1/8. Now here there's no remainder, which means that if you take 8 of these 3 1/8, they should fit perfectly into 25. So just imagine we take 8 3s, that's 24. Now we take 8 1/8. 8 1/8 is just 1. So we have 24 plus 1, which is 25. So this way of thinking has no remainder. So maybe, I just want to like relate it, if you're looking at things in a calculator, you're typically not going to work with the remainder stuff. You're going to work with it in this way. So if you punch in 25 divided by 8 into a calculator, you might get 3.125. That 3 is that same 3 we got over here, over here. The 0.125, that's just 1/8 as a decimal. So if you were to just ignore this, the 0.125, then you would have that whole part. Okay, so that's kind of all I want to tell you guys. So when you see all these forms, it just depends what you're going for. Do you want to view it, do you want to think about it in terms of like a whole number remainder, or do you want to work with like precise fractions and no remainders? But the concept is the same. Now, for those of you that want sort of the general terms and stuff, like I said, don't stress out about this, but you can take a look at this. So n is called the dividend, so that's our 25 in our example. D is the divisor, that's the thing you're dividing by, so in our case that was the 8. And then Q is the quotient, think of that, that's your answer. So in our case that was a 3. So we basically did 25 divided by 8 was 3 1/8. So the R is the 1, that's why the R is the 1 here. So this is the same as we have on the right, except with general letters, so you can learn what the terms mean. So don't freak out if you're like, oh my god, I'm having trouble following this. So how do we get the second one from the first one? We just divided everything by D. N divided by D is just N over D. D times Q divided by D, there's no more D's, so that's where you get that Q, plus a fraction, which is R over D, which is that whole D you're just dividing by. So again, if you didn't follow this part, don't worry about it too much. The main point is you might encounter the form with the remainder or without the remainder. It means the same thing. Well, it doesn't mean the same thing. It's basically you're doing the same thing. It depends what format you want you're answering. All right, so I'll leave it there. Hopefully that was helpful. For mastery, like let's say you want to take this to the next level, what do you do from here? So for the next step, I recommend practicing everything we've done. So let's say doing 9,400 divided by 8 or something like anything of that nature. So we can do 347 divided by 9 and trying to get this 38 in your head and getting the remainder 5 in your head. So do this whole problem in your head. Now, to help you guys with that, literally to help you save hours of practice and get better fast, because you can practice this all you want, but you might not get very good, because there's a trick to doing this better in your head. So I highly recommend that you guys check out video number 3 in the Art of Math series on my channel, which is going to talk about this left to right trick. All right, I will see you guys in the next video.